In math today, we're going to continue to add the areas. Remember how we could break apart a shape into two different rectangles and then find the area of each and then put them back together to find the whole area? We're going to keep working on that. So on page 345 says oh my gosh, I'm struggling today. Study the example showing how to find the area of combined rectangles, then solve problems 1 through 6. The example here, the diagram shows how Ms. Rigby covers her bulletin board with colored paper. What is the area of the whole bulletin board? You can count the square units, and there are 32 square units. Or you can multiply the length and the width. So the length is 2 feet plus 6 feet. It's one way to do it, right? Which gives us 8 feet. And then the width is 4 feet. So then 8 times 4 is 32. Or could you do 2 times 4 and 6 times 4 and then add those together like we've done before? Yes. So use the bulletin board from the example to answer problems 1 and 2. So which bulletin board are you using? Point to it in your book. That one, right? Well, don't want that, but this one. Look at problem 1. Read it with me. Write an equation for the area of each colored section of the bulletin board. So look at the red section. What would be the equation that we would write for just the red section of that? Raylan? No, just the red section. 2 who can help her out? Amy?
2 times 4.
Right, because if it's 4 over here, is it going to be 4 right there?
Yes.
Yes. So what's the red section equation?
2 times 4.
Say it again.
2 times 4.
Write it down. Do you know what 2 times 4 is?
Yes.
Go ahead and solve it then. Okay, now let's look at the blue section. What's the length of the blue section? Connor?
6.
And what's the width of the blue section, Lucas? 4. So what's our multiplication equation going to be, everyone?
6 times 4.
Write it down. Go ahead and, did you solve for both areas? Everybody, what's 2 times 4?
8.
8. Anybody know what 6 times 4 is? Jenny? 24. Okay, so now we're going to use that information that we just wrote down there to help us with part 2. Add the areas of the 2 sections. So what are we going to add together? What and what? Everybody?
28 and 24.
Does it matter which one we put first? No, especially if I write it like this, it doesn't matter, does it?
No.
But if I write it like this, it's easier to put the larger number on top, right?
Yeah.
So figure out, what is 8 plus that 24? Or that 24 plus that 8? They already told us the answer though, didn't they?
Yeah.
So what is it, everybody?
32.
32 what?
Square.
Square feet. Can I abbreviate square?
Yep.
Can I abbreviate feet?
Yep.
Sure. Okay, problem 3. Are we ready?
Yep.
Baxter's Dog Run has a small covered section and a large open section. What is the total area of the dog run? Show me how you're going to solve this right now on your own. Is there more than one right way to solve this?
Yeah.
Sure there is. I can find the area of this smaller part of the dog run. And by doing that, what would I multiply together?
4 and 3.
Right. Oops, I don't have my pen going, do I? So I would multiply that and that. What's 4 times 3?
12.
What's the next thing I would have to do if I'm doing it this way? Then what am I going to have to multiply?
4 times 6.
Right, then I have to look at the bigger part of the dog run, that's 6. If it's 4 over here, is it going to be 4 here?
Yeah.
Sure it is. So now, 6 times 4.
20.
And what does that equal?
24.
24. Am I done?
No.
No. Now I have to take that area and do what? I have to add it all together. So what's 24 plus 12? 4 plus 2 is?
6.
2 plus 1 is?
3.
Okay, so that's one way to solve for that. Some of you others might have done it this way. You might have added those right away. What's 3 plus 6?
9.
So the whole length of this is 9 meters. What could I do then, now that I have found that that length is 9? Connor?
Then you multiply it by 4.
Right. 4 times 9, or 9 times 4. What does it equal?
36.
Still 36. And yes, I need to label my answer, don't I? 36 square meters. The M is meters. All right, let's look at the next page. Number 4. This name is Joaquin, okay? Read this problem with me. Problem 4. Joaquin makes 2 paintings on small cards. The diagram shows how he hangs them together on the wall. Fill in the blanks. The gray area, so point to the gray part. You have to solve for the area of that gray part right now. And then you're going to write that on the line. How many of you have found the area of the gray part? What did you multiply, Amy?
5 times 6.
Anybody else do that? Yes or no? Yes. And everyone, what is 5 times 6 or 6 times 5?
30.
30. So the area of the gray is 30 square inches. Solve for the red area. How did you solve for the red area? What did you do, Jenny?
I did 4 times 6.
Did anybody else do that? 4 times 6 or 6 times 4? Everyone, what is 4 times 6 or 6 times 4?
24.
24. And yes, that's correct because this would also be 6 down here, wouldn't it? So we were looking specifically at that red part. Now, to find the area of all of that, what are we going to do?
Add.
We're going to add 30 plus 24. And that gives us a total area of
54.
54 square inches. Okay, 5. Show how to find the area of figure A. Friends, the whole thing is figure A. So go ahead and find the area for number 5. Two different ways to solve this. I see some of you doing it one way and some of you doing it the other way. So we'll go through both of those ways. All right, if this is 7 over here, what is this over here?
7.
It is also 7 feet. So for this first rectangle, I'm going to solve to find the area of that one. So what do I need to multiply for the rectangle on the left?
3. No.
What do I need to multiply for the one on the left, Connor?
5 times 7.
5 times 7. What do I need to multiply for the rectangle on the right? Natalia?
3 times 7.
Is it okay if I write it like that?
Yeah.
Certainly. What's 5 times 7, everybody?
35.
And what's 3 times 7, everybody?
21.
Okay, if I add those together, looking at my ones first. What's 1 plus 5?
6.
What's 2 plus 3?
5.
Okay, so that's one way. Do I need to label my answer? Yes, I do. What is this going to have labeled behind it? Square feet. Square feet. Okay. Then I saw some of you others doing it this way, where you added those right away. So 5 feet plus 3 feet gave you 8 feet times 7 feet. And 8 times 7 is, in fact, 56
square feet.
Exactly. Does it matter which way you solve it?
No.
No. Let's look at 6. Mila and her mom, or Mila, I'm not sure, and her mom are tiling the playroom floor with 2 colors of tile. They have 70 dark blue tiles and 30 light blue tiles. Each tile is 1 square foot. The diagram shows Mila's plan. Here's what we're doing first. A, show how to find the total area they are tiling. So find the area of both of those rectangles all together. Go ahead and do that right now. Okay, let's take a look at this. Some of you might have added those right away to give you 9 feet across there. And then you would have multiplied 8 times 9. Some of you might have looked at this 8 feet and this 5 feet and multiplied them together first. And then looked at the 8 feet and the 4 feet and multiplied those together. Again, does it matter which way you're more comfortable with? No. What's 8 times 5? Everybody? 40. What is 8 times 4? Everybody? 32. So 40 plus 32 is 72. I'm going to write it over here because I'm kind of out of space. Is this, adding those together, 5 plus 4 is 9. Is 8 times 9 72?
Yes.
Yes. So 72 square feet. All right, now, will Mila's plan work with the tiles she has? So she has 70 of these dark blue tiles. And how many light blue tiles? 30. What did we say the area of the dark blue tiles was? 8 times 5 is?
40.
Okay, so this is 40. And the area of the light blue tiles, 8 times 4 was? 32. Is her plan going to work? Does she have enough dark blue tiles? This is what she has. That's the area. Does she have enough dark blue tiles? Yes. This is the area of the light blue. This is how many tiles she has. Is that going to work?
No.
Why not?
Because
Why is that not going to work, Connor?
Because there's only 30 light blue, so they're too short.
Right. So does she have enough dark blue,
Yeah.
but not enough light blue? Let's write that down here. Will Milla's plan work with the tiles she has? No, because she has enough dark blue, but not enough light blue. Once you have that, just put your pencil down and I'll know you're ready to move on to the next session of lesson 16. All right, friends, this next part is we're still finding the area, but what do you notice about the shape they've given us? Is it a perfect rectangle?
No.
No, these are non-rectangular shapes. But in this, can you see rectangle shapes somewhere?
Yes.
Where do you see rectangle shapes? Do you see two rectangles in there?
Yes.
Or a rectangle and a square in there?
Yes. Yes.
Does anybody, and you might see it differently, does anybody see this
Yes.
and that?
Yep. Yep.
Okay. Did anybody see this and this?
Yep. Yes.
Yeah. Here's the other really cool thing about this is we can break that apart just like we did before, even though it's not a rectangular shape. We can break it apart into rectangular shapes. Okay, so I want you, hold on, let me jump ahead. Let's just jump at, turn the page. We're going to jump ahead. Let's look at the examples they give us. It says Elsa uses 1-inch square tiles to build the shape shown. What is the area of Elsa's shape? Well, it's a small enough shape, it would be easy to count the squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 square units. But like we talked about before we turned the page, there's different ways to break Elsa's shape into rectangles. One way was to have this one that has an area of 8 square inches and this that has 2 square inches. And if you add 8 and 2 together, what do you end up with? 10. Or some of you saw it this way. This rectangle has an area of 2, 4, 6 square inches and 4 square inches. What's 6 plus 4?
24.
Also 10. Okay, so Does it matter which way you see it to break it apart? No. That's the really, really cool thing with these. Okay, so now, thinking about the model it, these two ways. Remember the way you saw it when we first looked at that shape? I want you to go with that way. So look at the first way. Oh, they're having us do both of them, sorry. Look at the first way, and we're gonna write the two equations for this one. So looking at page 300, what is that? I don't even know. 349? 349. What's the equation that we would write? The first equation that we would write looking at it broken apart like this. 1, 2, 3, 4. 1, 2. What's our equation we would write to give us that total amount of the 8 for just this part that's broken off? 1, 2, 3, 4. 1, 2. Raylan?
2 times 4.
Yeah, 2 times 4 or 4 times 2. Let's write that down, friends. I'm going to have you write it down. I'm not going to because I'm going to keep going from page to page. So did you get that first equation written down?
Yep.
And what do we know that it equals? 4 times 2 or 2 times 4 equals 8. Now, there's another part that's broken off. How many here?
2.
How many here? 1. What's 2 times 1 or 1 times 2? 2. Let's write that equation down right beside our 4 times 2 or our 2 times 4 equation. You got it?
Yep.
Okay, we have those two equations with the two areas. Take those two areas that you came up with and put one here and one there. What did you get for your first area? 8 plus
2
equals 10. So the total number of Elsa's shape is 10 square inches. You got it?
Yep.
Even here? You wrote 10 again?
Yeah.
Okay, let's look at part 2. We're going to look at the second way that Elsa's shape was broken apart. And we're going to write those two equations that go with this. So what's your first equation going to be? 1, 2, 3, 1, 2. What would that be? Everybody.
3 times 2.
Right, 3 times 2, or it could also be 2 times 3. So did you get that written down? And what does 2 times 3 or 3 times 2 equal, everybody?
6.
Okay. Look at the second shape. 1, 2, 1, 2. What's that equation going to be for right here? Connor?
2 times 2.
2 times 2, and that equals
4.
4. So now take your area from each of those, write those there, and add them together. What do they both equal? Still 10, it was just broken apart in a different way. We're going to skip that for now. Let's take a look at actually doing some of these. Look at all that. But it's no big deal. It's seriously no big deal. Because I'm going to show you the tricks to help you solve these. Are you ready to learn them? Stand up. Jump up 5 times. 5 times. 5 times. Stand up. Shake out all the weirdness that you have inside you. Get it all out of you. We can't be weird anymore. We're getting rid of it. Shaking it out. Okay, deep breath in. Exhale. One more deep breath in through your nose. Exhale. Have a seat. Okay, let's take a look at these. Math brain, turn it back on. Here we go. What is the total area of this shape? Show your work. Now, I don't know about you, but I could break that up into two parts. How about you? Do you see where that could be broken up into two parts? For me, I'm looking at this and I know the whole length of this is 14. Now, part of it's missing here, right? Because it's not complete. So what I could do is, that's not straight, I know, but I would draw a line right there to break that apart. Because if this is 14 up here, what is this part here going to be?
14.
It is also 14. All right. Now, is the whole thing 10 meters? The whole width of it 10 meters now?
No.
No, it's not anymore. What is the width right here? Don't say it out loud. If you know it, put your hand on your head. Like, oh my gosh, I got it figured out. The width of just this part right here. Does it have a twin on the other side?
Yes.
What's the twin number over there?
4.
What is it, everybody?
4.
It is 4. All right. So do I know all of the measurements of this rectangle? 14 and 14, 4 and 4. Not so hard, was it? Now let's take a look at this other rectangle. I'm going to go a different color. We'll go blue for this one. It's not 10 anymore, is it?
No.
No. What is the width of this side of that rectangle? Do you see the number that has the arrow going to that part? What is it?
6.
It is 6. 6 is going right to there. So if this side is 6, what is this side? It is also 6. It's a twin. So is 4 plus 6 that 10 that was there? Yeah. All right. What is the length of this rectangle? The length of it. What does it say it is? 9. So what's the length of it up here?
9.
It is also 9. So now I have 2 rectangles, don't I? I have a 14 by 4 rectangle, and I have a 6 by 9 rectangle. Now, have we been practicing when we multiply a number by 14? No, we haven't practiced that. So, wrong color. 14 times 4. I'm going to break that 14 apart. I know how to do that. I have 1 10 and 4 ones, right? That gives me my 14. What's 10 times 4? 40. And what's 4 times 4? 16. What's 16 plus 40? Everybody.
50.
So what is 14 times 4?
56.
Write that down with me. Did we just find the area of that long, skinny, flat rectangle? Yeah. Now what do we need to do?
Figure out the other.
We have one more rectangle, don't we? What's going to be the multiplication equation for this other rectangle? Amy?
6 times 9.
Right, or 9 times 6. So what is 6 times 9 or 9 times 6? Everybody.
54.
What?
54.
Okay. Are we done?
No.
No, we're only partway there. What do we have to do next? We have 56 for the area of that top rectangle and 54 for the area of the bottom rectangle. What do we need to do? Add what?
56 plus 54.
Okay, so let's do that. 56 plus 54. What's 6 plus 4?
10.
I have to do some regrouping, don't I? Now, what's 5 plus 5?
10.
Plus one more.
11.
So what's the total area of that non-rectangular shape? 110 what? Square meters. So just because they don't have the lines in them, like we've been practicing, doesn't make it any harder, does it? We just have to put lines in there to help ourselves out. Are you ready to practice another one with me?
Yep.
Okay, let's look at 6. What is the area of this shape? Okay, so we could, let me get a writing utensil here. We could make it into that, right?
Yeah.
Or we could do that. Doesn't matter which way I break it up. Should we break it vertically or horizontally? Show me which way you want to break it. Majority says horizontally. Okay, so we're going to do it that way. We're breaking it this way. Break yours up this way. All right, friends. We're going to have to look closely at these numbers though, aren't we? We've got to pay really close attention because we broke this apart here. So now if the length of this is 7 centimeters, what is this length?
7.
It is also 7 centimeters. What is the width over here? Look at where this arrow is pointing. So what is the width? Everybody? 2. So then that means what's the width over here? 2. All the sides and the widths, or the lengths and the widths, are the same on both sides now. So what can we multiply to find the area of that top rectangle? Amy?
2 times 7.
2 times 7. Or if you wrote it 7 times 2, would that be okay?
Yep.
Definitely. Friends, what's 2 times 7 or 7 times 2?
14.
14. Top rectangle. Check, we got it. Let's look at this bottom part. Now, what is the length of this entire rectangle down here? 8 centimeters. So then, what is the length of the top of that rectangle?
8.
It is also 8 centimeters. What is the width of both sides of that rectangle? Is it still 5?
No.
No, because we split that, right? It's not 5 anymore. What is it?
3.
It is 3. So if it's 3 over here, it is now 3 there. Do you see what we need to multiply to find the area of the bottom rectangle? What? What are we multiplying, everybody? 8 times 3 or 3 times 8? And what is 8 times 3 or 3 times 8? Raylan? 24. So now I'm done, right?
No.
No? You're saying I have to do more.
Yes.
What else is there left to do? I've done a lot of work already. I'm tired. What do I have left to do, Lucas?
We got to add both of the
Areas.
Yeah.
Okay. So what am I adding? What 2 numbers then?
14 and 24.
Okay. So this is what I heard all at different times, but it's what everybody said. So what's 4 plus 4?
8.
What's 1 plus 2?
3.
So what's the total area?
38.
38 what?
Square centimeters.
Is this any different than what we've been doing before?
No.
Not really. It just looks way different, doesn't it?
Yeah.
All right, let's look at 7. Opal draws this model of a picnic table. What is the total area of the picnic table? Now, that's way different, isn't it?
Yeah.
What do you think? What could we do here? No guesses? Where's my, oh, there it is. Okay. How about we kind of break it completely apart? Okay, so what if I say we look at this? What's the width? 3. Let's write that down. What's the length?
3.
Are you sure? What do you think, Connor? Or are you perplexed?
4.
Let's do this. Hold on. I'm going to sweep that off. So what if we pulled each one of these apart and we had how many different individual squares? If I broke all of them off of there,
5.
we would have 5 different squares, right? So we would have 1, 2, They're not squares, but you get the idea. So we have our 5 squares. What is the width of each square? It's 3 feet. The width is 3 feet. It's a perfect square, so it's 3 all the way around, right? So here we have so this is like saying 3 feet, 3 feet, 3 feet, 3 feet, right? This one's a confusing one. This one's kind of mean of them to put in here. Hold up. I think this might be the best way to solve this. Let's find the area of just 1 square. Okay? So it is 3 by 3. What is 3 by 3? 9. So then that makes this one 9. That makes this one 9. What about this one? This one? So here I have 1, 2, 3, 4, 5. There's 5 squares, and each square is 9 square feet. What could I do with that? There's 5 squares, and each one is 9 square feet. What are you thinking, Amy?
5 times 9 or 9 times 5?
What were you thinking? That same thing? Yeah, that's exactly right. Either 9 times 5 or 5 times 9. Does it matter which way you write it? No. So everybody, what is 9 times 5 or 5 times 9?
45.
So the solution is 45 what? Square feet. That was kind of weird, huh?
A little.
A tad bit. Okay, I think we'll stop there because I want to do formative loop. Okay, so go ahead and put your workbook in your crate.
We haven't done formative loop in a long time.
Yeah, it's been a while.